Now, so whenever you're ready.
Okay, this is another inner can, but this time the bottom is closed. It has a pipe. I've split the pipe actually into 8 little slots and bound it with masking tape, which is surprisingly good. I can blow air into that pipe, and so I can control the amount of air which is going into the primary air. In this case, the grate is like that. You'll see it's got some legs, and in that sense it can stand above that pipe. If you look in the pipe, it's actually cut away the bottom half of it. I didn't cut away the top half, I cut away the bottom half because I thought that would spread the air a bit better. So this grate goes in here. I can get it in. Tricky. I believe it's really worth putting it in for this video. More or less like that. And the blower, the fan, is connected like that. This has not been cut away, but you see lots more masking tape because there is a tiny axial fan in there. You can see that fan blowing, and you can control the air by twisting this across the fan. Okay, in other respects it's like the other stoves. You could put this over it, I think, and so on. Okay, now what about how will you support the pot? How will the flames come out? Well, one thing you could do is just make some piles of bricks either side of it and put that on top. And you can use that as a grill to grill your barbecue on the flames coming out. Another possibility we showed before was to have the lid like this one. The diameter of the hole is about half the diameter of the inner can. That's called a flame concentrator, and the pot, assuming you're boiling your water or whatever stands on there, about 15 to 20 millimeters high. In fact, I found having it higher, the efficiency dropped. Another possibility is to have something that's a bit propeller shaped. The effect of that is that the air gets stirred up as it comes through, and so the smoke which is burning, the pyrolysis gas which is burning in the air, gets more thoroughly mixed. But there's not actually much space for it to mix that well. But it does also spread the heat across a wider pot. So I quite liked that one for a while. Another is this, where you see I've made a handle, and I've made these little triangular pieces to hold the pot up. So put that one there, or not. Now I come to, I think there's one more pot holder, this one. This has a hole, again about half the diameter, and in this case I've put some insulation on the inside, and this cross is held in 4 tiny little slots in the lid. You need only hold 2 actually. And when you put the pot on there, you see it effectively divides the heat coming outside in the burnt in the burnt flames, divides it into 4. This is first thought, it's bad for mixing. It probably is bad for mixing, but it does have an advantage. If it's a bit windy, the wind cannot blow across there. So it actually, in windy conditions, it's probably one of the simplest but one of the best pot holders. I think we can stop there.
So now I've started.
Now, okay, this is a sheet of aluminium. It's 270 by 270 double, so it's 540 millimeters long, 270 wide, which, as it turns out, is about the same size as Dave Lello's stove. It can control the air by means of this lever. But this just lets air in, and it's drawn through by the rising heat in the burning chamber, the pot that's the part of the stove that's put on top. There's another one here, and this has here an electric fan, and it's driven by a power bank or a phone 5-volt supply. I actually found it much more difficult to mount that than I expected, and not only was that difficult, also, although I've made the hole the same, when you open it, you don't want it to be open to any incoming air, only the air from the fan. So I had to adjust the shape of it inside so that the air gets directed up into that triangle. Closing it off, fairly obvious how you measure, but surprising that you have to make it much wider than you think to close it off under both conditions, open and closed. Right, the other thing that I did was these tabs, turned up tabs. I decided that because I was going to be using different sizes of inner can, the best way would be to locate them by standardizing on a 60mm diameter hole. And this is an example. It goes on there. Now this is quite an interesting design, although it looks crap. It's interesting because the grate, put the grate out, you'll see that the grate does not have holes in the middle, and there's a reason. The reason is that when the pyrolysis gas is coming out, it doesn't all go upwards, some goes downwards, and then it puts tar all over this sliding mechanism. In fact, you can see some tar on there, on that one. And that tar can be quite bad and sticky. So by doing that, I've avoided getting tar into the works. The other thing that is interesting, and this Ben will realise, is that I've had trouble with these. I have made this gasket at the bottom to try to exclude air from going any other way except what the air I want to control. I made it by putting a mixture of crushed charcoal and my fire clay, and if you look at the edge you'll see it there. I think if you look at the bottom you will see this has also got a gasket made of crushed fire clay. So the difference between them is the white layer, I added some rubber sealant. They used this round baths and so on to seal out water. Another interesting thing about the way these bottom things were done, you can see it in that one. You see the screws. The gasket can sit on those screws. The screws go actually through, and they go, and I adjusted them so that the stove, the can, was resting equally on all four and vertically. And it was also about 5 millimeters clear of the aluminium base. So I think this was quite a good step in the right direction, because that is a good insulator, this charcoal, and the screws were sticking through. So I was able to spread this mixture, and it was held by the screws. The screw threads were holding it, as well as the fact that it's quite sticky. And so that could have, again, a layer of rubbery stuff added to it. You see, these have all got a 60 millimeter hole. This is the natural draft one. Let's go back to that for a minute. One thing that I've also experimented with was, how does the secondary air that comes up between the cans, how should that enter the stove? And I felt that it ought to mix, and it ought to also dwell quite a long time within the stove itself. Then it has a better chance to burn thoroughly. And also this can be made very simply, just with a Stanley knife, cutting the metal. You pierce some holes at the corners of 1, 2, 3, 4 holes, and cut out 3 sides, and you've made a flap. So this has 4 flaps, and by bending them in and out I can control the different amount of secondary air that goes in. The secondary air which comes up will tend to get turned down and spend longer within the stove. Then it sort of works. One other thing is that I found that sometimes when the pyrolysis gas, the smoke, is getting near the end, the flames are at the top near these. But as it really finishes, the fire transfers down to the charcoal at the bottom, the glowing coals of the fire, and having a little hole somewhere on the side seems to provide a tiny little pilot flame that helps the fire move down to the bottom. So you find there's quite a lot of patches, because I've experimented with different numbers of pilot holes. And of course there's good and bad in pilot holes, because it's putting uncontrolled air at different levels of the fuel, and it's only the air at the bottom that you can control. So it messes that up in a sense. But I found there is a bit of advantage in having that, what I call a pilot hole. Right, that's that one. This is a natural draft here. If I move it to the other side, then I can blow air through it. So where in the one position I need lumpy fuel, in the other position I can use sawdust. You could probably use rice husks and quite fine fuel like that. Where's the outer can? It's there. You have a choice of any of these lids to put on it in the normal way. So that In this case, I forget the reason why, I made the slots to take in the secondary air somewhat higher. And I'm short of cans, so never enough cans, it seems. One of the problems in Britain is that most cans seem to be about equal height and width, whereas in Germany and in the United States you can get quite nice tall cans. So I have found a 1¼ litre dog food can, which is this one. That's the full height. You can see that it's significantly higher. But the problem was that the normal British paint can is not, if I put it there, it would be sticking out the top. So I put it on these sort of two runners. I twisted some foil round bits of wood, and surprisingly that's been enough to stop the wood burning away. And so now I can put this taller one on there, and I can put this raised one, there, and I can put a lot more fuel in because I've got a lot more height. We tend to lose height at both ends because you need to lift the grate away from the bottom, and you need some space for the flames before it actually comes out of the stove. Right, one other thing now about outer cans. If you look in here, you'll see that it's covered in crushed foil. That is as an insulator. If you look in, I don't know whether you can see, but in there again there is crushed foil on the outside of the can, and there's cardboard around all that. And the reason for that is to try to make this very well insulated, because the whole idea is to try to get the flames inside as hot as you possibly can. The hotter the better. If it's hot enough, it breaks down all the tar into a mixture of hydrogen and carbon monoxide, which burns very, very cleanly. So insulate, insulate, insulate. And I think I showed one of the lids that had insulation under it as well. I've not always used the same method of insulation. That one has also got foil, but this is a thicker foil. This is like the Chinese restaurants serve up their meals. And if you can find a big baking sheet made of that stuff, you can cut it up. But I can't find a supply of that kind of sheet, but that works quite well. Right, now those are all the natural draft TLUD designs. Say natural draft, they should work just with that natural draft. And we'll stop there before we move on to another aspect of design.